Hi, good day. My name is Mary Ann Joyavero and I'm gonna discuss to you in this video the industrial water supply system. Now, our objectives in this video are to learn what is industrial water, the uses of industrial water, and the process and how to reuse water that has been used during the production of the products. Water is very essential to most industries, and it is widely used for a variety of purposes. Now, manufacturing and some other industries use water during the production process of creating their products or cooling equipment used to create their product. Industrial water is used for the fabrication of the product, processing, washing the product, diluting the product, cooling the product, and also for the transportation of the product. And it is also used in the smelting facilities and producing chemical products like toothpaste, shampoos, conditioners, dishwashing liquids, and some other chemical products you use in your houses. And also for producing food like canned goods, instant foods, ketchups, powdered milk, and many more. Also for producing paper products like tissues, paper bags, paper cups, paper plates, paper box, you name it. Even though industrial sector consumes less water than agriculture and domestic users, it has high pollution potential that releases complex pollutants. That's why there were laws imposed to prevent industrial pollution. The first law that was imposed to prevent the industrial pollution was the reuse of water to its maximum extent. Water was used and wasted when it was abundant. Instead of keeping water in a closed-loop system like this, it is often used in a linear system. The second law that was imposed was to use treatment options that require large quantities of chemicals and energy only if low chemical use or energy use options are not available. Options requiring large quantities of chemicals or large amounts of energy are often recommended by consultants or suppliers to increase their profit. Instead of costly reinforcement cement concrete tanks, one can use earthen bond with low-cost lining. The third one is to avoid water wherever possible. Avoiding water is a major principle adopted by many industries. Water cooling is being replaced by air cooling in thermal power plants, cement plants, and other industries. Now, the fourth one is the segregation of wastewater with different characteristics. Different processes from industry are likely to have different characteristics and consequently, they have different significance during water treatment. For example, mixing of organic and inorganic waste will lead to the inhibition of microbial activity during the treatment process. Similarly, mixing hot water like boiler blowdown with wastewater streams at ambient temperature may kill microbes in the treatment plant, which may affect the performance of the effluent treatment plant. That's why it is important to segregate the wastewater streams into a number of streams in complicated processes such as oil refinery or integrated steel plants, and then treat the individual streams as necessary. The fifth law is to minimize the carbon footprint. Carbon footprint is the amount of carbon dioxide and other carbon components emitted due to the consumption of fossil fuels by a particular person or a group. Components that are responsible for a high carbon footprint during construction are over-designing and the use of large quantities of cement and metal, components that are responsible for a high carbon footprint during operation are electromechanical devices such as pumps, scrapers, aerators, and heaters. These are the sample pictures of the aerator, the heater, the pumps, and the scrapers that I mentioned earlier. Next is research and design the manufacturing unit to attain sustainability. If a manufacturing unit is not designed in the initial stage of the project to attain environmental sustainability, its incorporation in the latter stage of the life of a manufacturing unit would be costly and may not be feasible. And last is the investment in human resources. Most industries do not plan human resource investments. As a result of poorly trained and knowledgeable workforce, both in industry and in regulatory agencies, many countries have ended up paying in terms of environmental degradation. Industries with low dissolved solids will have an advantage in the most of the pollutants because it can be removed by physical operations, but care must be taken to remove toxic chemicals to a safe level. Industries with low amounts of inorganic materials can be treated easily if the organic compounds are not toxic to microbes. Sustainable options include acclimatization of microorganisms to effluents and physico-chemical treatment methods. Good manufacturing practice, which separates different streams of effluent and separate toxic streams, can reduce the burden on the biological treatment system. Material from garment washing, metal finishing, and surface coating industries usually contains low amounts of dissolved organic content. Low amounts of dissolved organic contents are mixed with sewage to optimize the nutrient supply to the biomass acting on the wastewater. The biological systems need to have optimum biomass to form settleable flocks to enable them to be removed by settling. If the industry discharges organic compounds that need treatment by acclimatized microorganisms, the setup should be commissioned with a gradual increase in concentration of such compounds in the treatment. Units are operations during the commissioning stage until an optimum condition is reached. Now, different wastewater types should not be mixed because of the difficulty of purifying the total wastewater output. Instead, each industry should purify and condition its industrial wastewater to levels that are satisfactory for further utilization in particular technological process. So here's the basic scheme of water supply for industry. First, it'll go to the preliminary purification. After that, it'll go to the solid waste or water distribution. If it'll go to the solid waste, it'll go to the systems of equipment cooling, water cooling, then the accumulated salts disposal. If it'll go to the water distribution, it has three options. Either go to the systems of equipment cooling, technology processes, or water sub-purification. If it'll go here, after that, it'll go to the special manufacturers, disposed waters, local purification, and then it goes back to water sub-purification. If it'll go to the technology processes, after that, it'll go to the disposed waters, neutralization and purification, mechanical suspensions removal, and to the water conditioning or solid waste. So if it'll go to the solid waste, it'll go to the storage recovery. But if it'll go here, after that, the water will return to water distribution. So these are my references about my topic in this video. So that's all for this video, and I hope you learned something, and you have any questions, you can PM me or email me on my Gmail account, mhavero.440127@umindanao.edu.ph, or you can PM me on my Facebook account. My name is Mary Ann Joy Havero, and have a good day.